Hello friends, today in Big Data Analytics we are going to see about data architecture design. Introduction. Big Data Architecture is a system in which we can do ingestion, storage, processing and consumption of data for our business, studies, etc. These are the 5 layers of Big Data Architecture. Layer 1. Identification of internal and external source of data. In this, we can identify the source of data that it is collected from internal or external source. Internal source means the data is collected from our surrounding. Example, in a company, we can get the employee ID, name, salary. This is called internal source. External source means the data from outside, that is social media, Facebook, Google, Twitter, etc. Functions of this layer. First one, sources for injection of data. In this, before the injection of data, we should identify the source so that we can easily perform the task. Second one, push or pull of data from the source of injection. In this, we can do amount of data needed at injection layer 2 so that the data can be pushed from layer 1 or pulled by layer 2 as per the mechanism of usage. Third one, data types for database, files, web or service. This is used to find the nature of source that can be saved as database, file, etc. Last one is data format. In this, we should find the data format as structured, semi-structured or unstructured so that we can easily inject the data according to its structure. Layer 2, data injection and acquisition. Layer 1, we have collected the data. We have to insert that data into your database or file using data injection, and then the data acquisition will filter and clean the data before analysis. Function of this layer. First one, injection using extract, load and transform ELT. Here, data injection is a backbone of any analytics architecture. The ELT will extract the data from previous layer and then it will load and transform the data into a data warehouse so that data analysis can be done. Second one is data semantics, such as replace, append, aggregate, compact, fuse, etc. By using this, we can replace the data, append the new data element into a existing database, and we can aggregate the different sources of data and compact the data. Third one, pre-processing, validation, transformation or transcoding requirement. Before executing the data, we should pre-process the data. We need to check the missing data, unnecessary data and another inconsistency for the analysis, and we have to validate and correct the data according to its. Last one is injection of data from sources in batches or real time. When the data is ingested in real time, then it is ingested immediately as soon as the data arrives. Example, we are getting a message from a bank for withdraw and deposit. When the data is ingested in batches, then the data items are ingested in data sets for periodic time of intervals. Layer 3, data storage. In layer 1, we have collected some data. In layer 2, we have to inject that data. Here, in layer 3, we have to store that data. These layers focus on where to store such a large data efficiently for further access of that data. Functions of this layer. First one, consideration of types, historical or incremental, format, compression, frequency of incoming data, patterns of querying and data consumption. Here we have to consider the format of data, that is structure, unstructured, semi-structured, so that we can save easily, and we have to check the frequency of incoming data. This helps the determine and store mechanism. And the compression of data is used to save the data memory and data consumption. Second one is Hadoop distributing file system. These HDFS store the data in several locations, that is name node, which is the master node, that split the data and distribute to different Glita nodes. Each data block are replicated by default and distributed across the different data node. In case of any of the data node is failed, we can retrieve the data using a replica. This is the advantages of HDFS. Third one is no SQL data stores. It allows the high performance on large data sets and it can store unlimited set of data in any type. So some of the no SQL data stores are MongoDB, Cassandra, Graph Database and HBase. Layer 4 Data Processing. This layer processes the data which we have to collected in the previous layer. Function of this layer. First one is processing technology. For processing the huge amount of data, we have some technology: MapReduce, Hive, Big, Spark, etc. Second one is processing in real time, scheduled batches or hybrid. In this, the processing of data in real time, scheduled batches or hybrid depends upon the data which we have. The last one is synchronous and asynchronous processing. While processing, sometimes it will execute without interruption from first to last. But sometimes we may face problem while executing the data due to interruption. The last layer is layer 5, data consumption. This layer consumes the output provided by the previous layer and present them to the relevant output. Functions of these data. Here. Export of data sets to cloud, web, etc. Here we will export the data sets to the cloud or web application that lets you to run the queries of large data sets faster. Second one is data set usage, BBS, BIS, knowledge discovery. So that the data usage of reporting and visualization that covers the business goal that needs to access the data, analyze the data and integration into a business decision making and knowledge discovery to find the pattern that leads to access knowledge from lost data sets. Third one is analytics. Analytics can be done in real time, near real time or scheduled batches, and after that the reporting visualization can be done. Benefits. By using this big data technology as Hadoop, we can reduce the cost of a project and also we can make a faster and better decision in real time. We can also analyze the mindset of customer so that we can create a new product, etc. That's all about today's section. Thank you, friends.